Okay, this is a continuation of section 2.4, more about linear equations. Now, in this part of the section, we're going to talk about being able to write equations of parallel and perpendicular lines. And we've talked about being able to find the equation of any line that we want, whether it be point-slope form, slope-intercept form, or standard form. Okay, and now what we're going to do is we're going to find a little bit more specifics about certain lines that are parallel to each other and perpendicular to each other. Okay, now, simple thing about parallel, again, parallel, just kind of a review about geometry here a little bit. Parallel lines are lines that never intersect, lines that never cross each other, they'll never ever touch. Perpendicular lines are lines that intersect to form a perfect 90-degree angle. Okay, now we're going to get a little bit more specific in terms of the equation parts of things here as we talk about parallel and perpendicular lines. Now, how to write the equation of parallel and perpendicular lines. As you look at this, the very first step gives you a very important step that you might want to put a star next to this. Parallel lines have equal or the same slopes, so the slopes are exactly the same. Perpendicular lines have opposite reciprocal slopes, or what I call flip slopes. Okay, their slopes are flipped. The numerator becomes the denominator becomes the numerator. We take the reciprocal. Okay, these next three steps here are steps on how to actually go through and find the equation of your line. So identify the slope of the line that they gave you in the problem. So the first thing you got to do here is you want to figure out, okay, what's the slope that they give you? All right. Now, depending on whether it's parallel or perpendicular is going to determine on whether you have to change your slope or not. Okay? Figure out the slope that you need for your line and use the slope from the original problem to find your slope. So for example, if the slope of the original line was 3 and we want a slope that's parallel to that, our slope's going to be 3 as well. If we wanted to be perpendicular to that slope of 3, then it would be negative 1/3, which would be the opposite reciprocal of it. And we'll get into all that as we look at an example. Finally, you're going to use your slope and pick one of the points to given to find the equation of your line, just like what we've done the last couple days in terms of putting it into point-slope form. Probably going to convert it to slope-intercept form and then be able to graph. Okay. All right. A couple other things here in terms of parallel perpendicular lines. Essentially the same thing that I just got done talking about. You'll notice here with parallel lines the slopes are equal. Okay. You'll notice here the slopes of this bluish colored line right here, slopes are going to be exactly the same. So you'll notice here M1 is equal to M2. And you'll notice that these B's, which again is the y-intercept, are not the same. Where it crosses the y-axis here and here are not the same. So the y-intercepts are different. So on here you might want to write this down as well, that slopes are the same.
Lily Bear.
And your y-intercepts are different. Okay, your slopes are the same and your y-intercept is different. Okay, and you'll notice again that these two lines here never intersect. Now, as you look at perpendicular lines, okay, perpendicular lines have negative reciprocal, or what I call opposite reciprocal slopes of each other. You'll notice here, here's the two lines. You got the blue line, the red line. They intersect to form a 90-degree angle. The slopes are going to be opposite reciprocals of each other. And the y-intercepts are going to be different. They're not going to be the same either. Okay, so for example, let's take a look here. If I originally said that my slope was 2/3, a slope that is perpendicular to it, perpendicular is, by the way, is an upside down T. That's what perpendicular means. It's a symbol for it. So a slope that is perpendicular to it would be opposite of that, and since it's positive, it's going to become negative, and I'm going to flip these two. So this is going to be negative 3/2. That's the opposite reciprocal slope. Same thing if I had a slope of 4, I can write that as 4/1. The slope that's perpendicular to that would be the opposite of it, which would be negative, and flip that fraction, which is 1/4. Okay, so it kind of gives you an idea of the importance of figuring out your slope in parallel and perpendicular lines. Okay, now let's take a look at some examples. First example here. What is the equation of each line in slope-intercept form? Key here that they've given you is they want it in slope-intercept form as your final answer. You can put it in point-slope form first, but then you have to convert it. Okay? So a line parallel to y equals 6x minus 2 through the ordered pair 1, negative 3. Okay, so the first thing that we want to do here is identify from this equation right here, what is the slope? And the slope in this equation is 6. Okay? We need a slope that is parallel to that. So our slope is going to be the exact same. Our slope is 6, and we're going to use this ordered pair of 1, 3. Okay, so now I'm going to plug this into the equation of point-slope form. Again, point-slope form, y minus y1 equals the slope times x minus x1. Plug these two ordered pairs in, and the slope, so it's going to be y minus 3 equals 6 times x minus 1. And again, it said, got to put it in slope-intercept form. So I'm going to have to convert this. Distribute this 6. Y minus 3 equals 6x minus 6. Add 3 to each side in order to get slope-intercept form. We've got to set or get y by itself. So if I add 3, I get y equals 6x and minus 3. So this is the equation of the line that is parallel to this guy. Notice, if you look at the slopes are the same, and the y-intercepts are different. Okay, so we found the equation of a line that's parallel to y equals 6x minus 2. And now that I look at this, I think we made a little mistake here. This is supposed to be negative 3. So then that would make this a plus and this a plus. And then it's going to change this 3 here to a 9 because we're going to subtract 3 now from each side. Okay, got to pay attention to those negatives. All right, let's take a look at example number 2. Example B. What is the equation of the line in slope-intercept form? Again, it asks you for it in slope-intercept form, so your answer has to be in that. Now they want the line perpendicular to y equals 4x, negative 4x plus 2/3 through the ordered pair 8, 5. So here's the equation that they give us. First thing you got to do, figure out what is the slope of that equation. The slope of this equation is negative 4. Our slope has to be perpendicular to that. So perpendicular means opposite reciprocals. So their slope is negative 4. Our slope is going to be a positive, and if I take negative 4 over 1, take the reciprocal, I'm going to take it, and our slope is 1/4. And again, we're going to use this ordered pair of 8, 5. Okay, so again, I'm going to plug this in. So y minus 5 equals 1/4 times x minus 8. Put it in point slope form. Distribute the negative, or distribute the 1/4. So y minus 5 equals 1/4 x, and 8 divided by 4 is 2. Add 5 to each side, and y is going to equal 1/4 x plus 3. This is the equation of the line that is perpendicular to this one, because again, if you look at the slopes, this slope is negative 4, this slope is 1/4. They're opposite reciprocals of each other, and the y-intercepts are different. Okay? Let's take a look now at that third example. What's the equation of each line in slope-intercept form? Again, got to be in slope-intercept form. Now, as you look at this equation's not in slope-intercept form originally, so it's really hard to figure out our slope. So, in order to put it in slope-intercept form, let's get y by itself to find the slope. So, I'm going to subtract 4x So I get 2y equals negative 4x plus 7. Divide every part by 2. And y is going to equal negative 2x plus 7 halves. Okay, now that I have the equation in slope-intercept form, I can figure out the slope. What's the slope of this line? Slope here is negative 2. Our slope is going to be the exact same because it said it's parallel. So our slope is negative 2, and I'm going to use this ordered pair of 4, negative 2. So I plug this into point slope form. Y minus negative 2 equals negative 2 times x minus 4. This becomes y plus 2. If I distribute the negative 2, I get negative 2x and plus 8. So now, when I subtract 2 here, y is going to equal negative 2x and plus 6. This line right here is parallel to this guy. And you'll notice the slopes are exactly the same, and the y-intercepts are different. Okay? So this ending concept of section 2.4 is the last part of linear that we're going to look at. Parallel and perpendicular lines. Okay, this is an important part of this section. You are going to see part of this on quizzes and tests. Okay, this concludes section 2.4, parallel and perpendicular lines.